During the last hurricane, we lost our Wi-Fi and internet connection, and so I decided to build a usable solar-powered battery backup system so that I could power my internet and my phone for a longer period of time than most UPS battery backup systems. Now, while this may look a little bit complicated, it's really quite simple, and I also built it so that it's expandable and also instructional. So for any system, you have to start with your solar panel. I chose a 50-watt monocrystalline solar panel. That's supposed to be the most efficient. The Renogy, for about $75, comes with the MC4 connectors attached to the back. I purchased some additional MC4 connector extension cords basically so that I can go wherever the sun is at in my yard. And this particular arrangement, all I have to do is take the tray and slide it in, and all of this will fit underneath that solar panel. As you can see, the first thing that you have to do is make sure you're getting voltage from your solar panel. We're getting 18.1 volts, and according to Renogy's instructions of how to start up your system, that's why I have the switches, is first you have to turn on your battery to the controller. So now the Wanderer, which is also a Renogy product, it's very simple. Just plug in your solar panel and go to your battery. So now we're going to go ahead and we're going to turn on and send the power to the battery. And you'll see we're charged up to 13 volts, and you'll see the little Renogy Wanderer is flashing. That's telling us that we're getting voltage, and you'll notice the voltage has dropped. So our controller is working correctly. Now, the reason that I purchased the Renogy is because it has nice, firm aluminum frame, monocrystalline. It won't bend or get too hot in the sun. It doesn't matter. If you get those flexible ones, who knows what will happen. I can also easily add on more panels later if I want to. And the reason I purchased the Wanderer solar control, because remember, you've got to have something to control that voltage, that higher voltage that's coming from your solar panel, is this one is so simple. You just plug it in, tell it what kind of battery you've got, and it does all the thinking for you. And also, this one does what's called a soft charge. So as my battery gets up to higher voltages, it starts to reduce the charge so my battery is not basically burned up or overheated. Now, the third key component is a battery. If you want to do that, I use the Mighty Max battery. It's a sealed gel battery, maintenance free, and it's made for cyclic operations like solar. I purchased this on Amazon, and it is made to draw down and then recharge. According to the research I did, you can only draw it down to 25% charge, or in this case 12.2 volts, without damaging it. So I ran 7.8 watt load for 11 hours. That's my Wi-Fi and my phone on this battery, and it ran for 11 hours. So for me, that's perfect. The fourth key component is the inverter. So in order to go from 12 volt DC to AC, you have to have an inverter. So my inverter There, see how we got our 113 volts as soon as we turned on the inverter? And also this inverter has a USB, so I can charge right off the inverter. Now I got a pure sine wave inverter. It's more reliable power, works well on computers and other things. Now you can hook everything up a number of ways, but fusing is needed to protect each component. You'll notice that I have little fuses for each component. For instance, I have some panel lights, which I think are kind of cute. They're little blue tail lights for over here. I got those from super bright LEDs. And notice now how my total wattage goes up and down when the lights go off. So there's my panel lights on. They just take a little tiny bit. I figured I could leave those on even at night if I needed to see what was happening in a power outage. I also added some other kind of lights. Some at the end of extension cord I put a nice little trailer light so I can have some emergency lights on a little extension cord. And you'll see that I installed the power, total power, because I wanted to see exactly what was happening and what each component was taking. I installed some little meters so I know when everything is on, then I know exactly what, I know it's on. It's like an on light switch. And I just installed some cooling fans too. You're going to need some basic tools to do it. I got some terminal assortment. You're going to need a voltmeter, just some basic tools. I had a soldering gun and a glue gun to make things with. You're going to need some other little tools. And I just used a piece of plexiglass so that I could put everything together and have a nice little control panel board. If you're interested in making it, there's a picture of what I did as far as the wiring diagram goes. And most of the components were bought on Amazon. Okay, well, I hope you enjoy. That's the little project that I had fun building.